Welcome. My name is Martin Litwack, a lecturer in the Mathematics and Computer Science Department at Kingsborough Community College. This video provides worked out solutions for Sample A of the CUNY Elementary Algebra Final Exam. Sample A can be found at the link in front of you. Your feedback is encouraged. You can email me at mlitwack@kingsborough.edu with comments and/or suggestions. Now, please keep in mind that most problems in math can be solved in more than one way. The methods I've chosen here may, therefore, differ somewhat from those used by your instructor. This is normal and to be expected. So if you already fully understand how to solve a particular problem type, you should probably stick with it. On the other hand, if you are having difficulty with a particular problem type, this video will hopefully help you understand it better. I have solved most of the problems in only one way in order to avoid confusion. However, occasionally I have provided more than one solution in order to more fully explain an underlying concept. Well, good luck and let's begin. Again, I encourage you to download this sample exam if you haven't already from the following link. Problem 16, like problem 15, contains a quadratic equation, but there is a difference. If you notice in problem 15 as well as 16, we have an x squared term, but there is no x term in problem 16. So we're missing the x term in this problem. And the method used to solve a quadratic equation when there's a missing x term is different. What we do is we make use of what's called the square root property. The square root property states the following. If x squared equals some number k, then when we solve for x equals either positive, the square root of k, or x equals negative, the square root of k. Now we know in a quadratic equation we usually have two solutions, so that makes sense. Okay, so let's see where we are with our problem. We cannot make use of the square root property immediately because our problem is 10x squared, whereas the square root property specifies just x squared. But if we divide both sides by 10, then we get on the left, let me put that down here, then we get x squared equals 49 when we reduce. Now we can make use of the square root property. So we'll have x equals positive the square root of 49, or x equals negative the square root of 49. Well, the square root of 49 is 7, so x equals 7 or x equals negative 7. So this answer of 7 or negative 7 corresponds to choice C. Problem number 17 makes use of the Pythagorean theorem. The Pythagorean theorem helps you to find a side of a right triangle when you're given two sides, their lengths, and need to find the third side. The formula is c squared, which refers to the hypotenuse, equals a squared plus b squared. Now, the c refers to the hypotenuse, as I just mentioned, and the hypotenuse is the side opposite the right angle. Over here is our right angle. A right angle is always present in a right triangle. And the hypotenuse is the side opposite the right angle. So the hypotenuse, the C, will be this side, whose length is 9. The A and B refer to legs. The other two sides of a right triangle are called legs. And either one can be A or B. So in this case, I'll just call this side A, and I'll call this side B. So now to solve for the x, which we're asked to do, we just make use of that Pythagorean theorem and plug in. So c squared equals a squared plus b squared. 9 squared equals 3 squared plus x squared. Now we see here we have a quadratic equation. There's no x term, it's missing. So we'll have to make use of the square root property. So we want to isolate the x squared term. So 81 equals 9 plus x squared. So we will now isolate the x squared. We'll subtract 9 from both sides. And we'll wind up with 72 equals x squared. The square root property says, let me finish that off over here. The square root property says that x equals the square root of 72, positive square root of 72, or the negative square root of 72. However, in a right triangle, you cannot have a negative side. So this solution will have to be discarded. You cannot have a negative length of a side. So the answer is the square root of 72, which must be simplified. It equals 36. 72 is the largest square, and 72 is 36. So they'll now get a divorce, as we've seen earlier. So we have the square root of 36 times the square root of 2, which equals 6 times the square root of 2. So the correct choice is A. Problem number 18 asks you to graph the solution of the inequality they give you. What we'll have to first do is solve the inequality. Now, an inequality is where the left side and the right side are compared by way of an unequal condition as opposed to an equation. The inequality symbols can be either less than. I remember less than by the sick looking L, L for less than or equal, greater than, and finally, it could be greater than or equal. Now we can solve for the inequality by placing the x's on the left or on the right. We'll do each. Keep in mind that the method used to solve these is very similar to the methods we use for solving equations. Let's begin by solving for x by placing the x's on the right-hand side. So we'll subtract 3x from both sides, and we'll get 5 is less than 6x minus 3x, or 3x minus 1. Notice we're just doing the same thing as if we were solving an equation. So we'll add 1 to both sides, and we'll get 6 is less than 3x. We'll divide both sides, and we'll wind up with 2 is less than x. Now we need to solve for x, but if 2 is less than x, it must mean that x is greater than 2. So our solution is x is greater than 2. Now what happens when we solve for x if we place the x's on the left? Well, we subtract 6x from both sides, and that gives us 3x take away 6x. The negatives went out by 3, so we'll get negative 3x plus 5 is less than negative 1. Now we'll subtract 5 from both sides, and we'll wind up with negative 3x is less than 1 negative, 5 negatives, negative 6. Now here's where you have to be careful. There's a principle in mathematics. So the principle is as follows. When dividing or multiplying both sides of an inequality by the same negative number, the inequality symbol changes direction. In other words, if the inequality was a less than sign, then it's going to go to a greater than sign. If it was greater than, it's going to wind up as less than. So over here, since we're going to have to divide by negative 3 to solve this inequality, we're going to have to change the direction of this inequality symbol. So the negative 3's cross out, you get x. Negative 6 divided by negative 3 is 2, but this inequality symbol is going to have to be greater than, since we divided both sides by a negative number. So once again, we see the answer is x is greater than 2. I would like to give you an example to show you why we need to change the direction of the inequality symbol when we divide by a negative number. For instance, we know that 2 is less than 4. Now, if we divide both sides by negative 2, the result is negative 1 on this side and negative 2 on this side. Now if you look at the real number line, you see that negative 1 is here, but negative 2 is to the left of it. It's more negative. So we see that negative 1, since it has fewer negatives, is actually greater than negative 2. Now we just showed that the solution to this problem is x is greater than 2. Now we're ready to graph the solution x is greater than 2. So we draw a real number line, and we'll leave a little empty space here where 2 is located, and we continue. Now since x is greater than 2, we're going to shade everything to the right of 2. And we'll indicate that the solution goes on indefinitely. The only question is the 2 itself included? We know it's not included because x is greater than 2, not greater than or equal to 2. So we indicate this by whether we fill in the circle at 2 or we don't. So when we have less than or greater than, strictly less than or greater than, so the number itself is not included, we do not fill the circle. On the other hand, if we have less than or equal or greater than or equal, so the number itself is included, then we fill the circle. So we see what we came up with corresponds to choice A. Problem 19 tests your understanding of function notation. You're given a function g, which is a rule, which says what to do for any input x. In this problem, our input x is squared and multiplied by 3. This is then added to 5 times the input. Finally, 2 is subtracted. G of 2 is asking us to determine the output for a specific input, namely 2. To determine g of 2, simply substitute 2 for x and then evaluate. So the input is x, and we're being asked to determine, to evaluate what is the result of the output for the specific input 2. So what we need to do is substitute x with 2. So the way I like to substitute is to put empty parentheses around the variable for which we're substituting. That's the first thing I like to do. That keeps us out of PEMDAS problems. And then substitute. So x is 2 and 2. So let's evaluate now using the rules of PEMDAS, the order of operations. So g of 2 equals, now we'll do the exponent first. 2 squared is 4. So 3 times 4 plus 5 times 2 minus 2. Next, we will do the multiplication that we see. So 3 times 4 is 12. 5 times 2 is 10 minus 2. So finally we get that g of 2 equals 12 plus 10 is 22 minus 2, which equals 20. So we see the answer is choice C, 20. Problem number 20 asks you to draw the graph that is represented by the given equation. Now there are different ways to graph a straight line from an equation. One way is to determine 2 of its points and connect them. If you look at each graph, you'll see that the coordinates of all their x-intercepts and y-intercepts are whole numbers. This should make it easy to find them. The point where the line crosses the x-axis is referred to as the x-intercept. Now, as with any point, there are 2 coordinates, an x and a y. But since the x-intercept is right on the x-axis, we see we have not gone down, we have not gone up, so the y value must be 0. And the x is whatever it is, wherever we are on the x-axis. The y-intercept is where the graph crosses the y-axis. And it too will have 2 coordinates, but you know something about one of the coordinates. Since we're right on the y-axis, we have not gone left or right, so that means the x value is 0, and the y is whatever it is. If you're having trouble reading the numbers on the particular graph, then what you can do is count boxes, and that will give you the result you need. So our plan is going to be to determine the x-intercept, the y-intercept, and then we connect these 2 points with a line. Given the fact that they gave us the equation in standard form, it's very easy to find these 2 intercepts. So we do as follows. To find the x-intercept, for the point xy that we're looking for, the x-intercept, the y is 0. So we'll plug in 0 for the y. That equals 12. So 4 times 0 is 0, so you're left with negative 3x equals 12. And dividing both sides by negative 3, we see the result is negative 4. To find the y-intercept, we will substitute 0 for x. So that will give us negative 3 times 0 plus 4y equals 12. Now negative 3 times 0 is 0, so that leaves us with 4y equals 12, and dividing both sides by 4 will give us y equals 3. So we see the x-intercept is negative 4. Now the only graph that has an x-intercept of negative 4 is graph C, so we see that's the correct choice. But let's look at our y-intercept. Our y-intercept is 3, and you see the y-intercept of choice C, graph C, does have a y-intercept of 3. Question number 21 asks you to write the equation of a line in slope-intercept form, given 2 points, negative 2, 3, and 1, negative 3 on the line. So we can distinguish these 2 points. Let's call this point the first point. It doesn't matter if this is the first point or the 1 comma negative 3 we call the first point. So instead of just calling both points x and y, in which case we cannot distinguish between the two, let's call this point x1 comma y1, corresponding to the first point they gave us, and x2 comma y2, corresponding to the second point they gave us. Now the 2 is not, or the 1 here, is not being multiplied, it's just a subscript. Okay, so we need to know what the slope-intercept form is. And the slope-intercept form is y equals mx plus b. Now you're going to have to find the m and the b. The m is the slope, and the b is the y-intercept. Now, they did not give you the slope nor the y-intercept directly, but we can still find them. And it makes sense that we can, since 2 points define a unique line. And since we know everything about that line, once we've determined we've been given a unique line, we can find its characteristics, including the slope and the y-intercept. Now, earlier on, you should have learned the formula for the slope. And the slope, which equals m in our example, equals the rise over the run. The rise is going to be the difference in the y's for 2 points, because the y's go up and down, divided by the difference in the x's of 2 points. Now substituting, we'll place y2, which is negative 3, minus y1, which is 3, over x2, which is 1, minus x1. x1 is negative 2. So that equals negative 6 over 3, or the slope equals negative 2. So we have found m. So we have found m. So now we can plug in for the m. So y equals negative 2x plus b. Now we cannot solve for b unless we find values for x and y. But we can do that quite easily because they gave us not only one xy, but two xy's, 2 points on the line. So you can plug in either xy point. Let's choose the second point since the numbers are smaller and it's easy to multiply by 1. So if we plug in y2 for y, we're going to get negative 3 equals negative 2 times x2, which is going to be 1. So let's finish solving for b. We're going to get negative 3 equals negative 2 plus b. We'll add 2 to both sides, and we'll come up with negative 1 is what b equals. Well, we now know the b. We found the m already. So the final equation is going to be y equals negative 2x minus 1. And that is going to be choice D. Problem number 22 asks you to find the equation of a line. The line here that they want you to find is the equation of a vertical line with a given point. Now if we look at the choices, we see choices A and D have the familiar x and y in them representing points, but choice B only has y and choice C only has x. Let's look at this a little more closely. When they ask you to find the equation of a line in general, what they want is the line in slope-intercept form. If you remember, the equation of a line in slope-intercept form is y equals mx plus b, where m is the slope and the b is the y-intercept. Now in this case, what they want is the equation of a vertical line passing through the point negative 5, negative 2. So if you remember, the first coordinate is the x value, so that places us here at negative 5, and the y coordinate is negative 2, which means we have to go down 2 units. So from the x of negative 5, we go down 2 units, and this is the point over here of negative 5 comma negative 2. And then you can draw a vertical line through the point. Now if we try to write the equation in the slope-intercept form, we're going to encounter a problem. Why is that? Well, the reason is because we have a vertical line here, and a vertical line actually has no slope. The slope of a vertical line is undefined. Now the reason for that is because of the arithmetic, the math that goes on in the slope formula. Remember, the slope is going to be the rise, which is the difference in the y's, over the run, which is the difference in the x's. Along a vertical line, since the distance from the y-axis to the line is constant, it's always the same, the x will always be the same distance away. So for example, we would have a point here, the x would be negative 5, and let's just say it's 3. You could choose any point. Now if we choose to try to find the slope for that line, let's call this the first point, and let's call this the second point. Let's plug in now, so we'll have negative 3 minus 3 over negative 5 minus a negative 5. In the numerator, you get negative 6, but in the denominator, you're going to get negative 5 plus a positive 5, or 0. So we get a 0 in the denominator. You cannot divide by 0. When we have 0 in the denominator of a fraction, we say that fraction is undefined. So there is no slope. So therefore, you cannot use the slope formula. Furthermore, if we look at that vertical line, we see the only thing that matters is the x. The y's don't matter because no matter what the y, the x is still negative 5. So the only thing that matters is the x. Only x matters. Well, since only x matters, our equation will only have x's in it. So we can therefore write x equals negative 5. And that is the answer. So summarizing, for a vertical line, as we've just seen, the equation is going to be x equals some number. And it can be easily shown that for a horizontal line, that the equation will be y equals some number. And so the answer is choice C, x equals negative 5. In question number 23, you're asked to find the slope and y-intercept of the given equation. The problem is, as things stand right now, this is the standard form of a line, ax plus by equals c. Now, to find the slope and y-intercept, you need the equation to be given in, well, the slope-intercept form, which is y equals mx plus b. So what we're going to have to do in this problem is convert the standard form into the slope-intercept form. In other words, we're going to solve for y. So 3x plus 4y equals 8. We'll isolate the y by subtracting the 3x from both sides. And we're going to be left with 4y equals negative 3x plus 8. Now you'll notice that I wrote negative 3x plus 8 instead of 8 minus 3x. But it does not matter the order in which we add, and you'll see the numbers are the same. Here we have negative 3x, here we have negative 3x. Here we have positive 8, positive 8. The reason I did it this way is because it more closely resembles the slope-intercept form over here of mx plus b in that order. And we'll finish up here by dividing both sides by 4. So the y's cancel out, and you're left with y equals negative 3x over 4 plus 8 over 4. So that equals negative 3x over 4 plus 8 over 4. Reduce this 2. So we see that the slope is going to be negative 3/4. That's what's multiplying the x, and we do have now the slope-intercept form. And we see the y-intercept is positive 2. That represents the b. So this is the y-intercept, and this is the slope. So that means that the proper choice is choice A, which states that the slope is negative 3/4 and the y-intercept. Now they give the y-intercept as 0, 2. But keep in mind that that means that the y-intercept is, that means that the point 0, 2 is right over here, right on the y-axis here. So that is the y-intercept of 2. Now if you want to see why I broke down, or why it was proper to break down this fraction here into two separate fractions here, I'll explain that to you right now. Otherwise, you can just go on to problem 24. Let's recall how you add two fractions with the same denominator. For instance, let's say you wanted to add 1/7 plus 2/7. Now you know since the denominators are the same, you're permitted to add the numerators. So we get 1 plus 2 over 7, which is equal to 3 over 7. Now since we have an equation, it does not matter which is on the left and which is on the right. So we could swap the two sides and write it in the reverse direction. What you see now is that we have broken down the original fraction into two small fractions. Whenever you see terms, things being added in a numerator, you can break it down so that each term can be expressed separately with the given denominator. So we'll do the same thing here. We'll say y equals negative 3x over 4 plus 8 over 4. We'll reduce the 8 over 4 to get what you were shown on the previous page. Now in problem number 24, you're being tested on your knowledge of proportions. Now a proportion is where you set two ratios equal to each other. A ratio is simply a fancy word for fraction. In a proportion problem, you're given a relationship between two different quantities or values, here gallons and dollars, and once you're given that relationship that 6 gallons costs $24, you're asked to determine how much money 10 gallons costs. So we set up a proportion. 6 gallons is to $24 as 10 gallons is to X dollars. Now keep in mind, if you put gallons in the numerator of the left ratio, you have to put gallons in the numerator of the right ratio. At this point, since we have a proportion, we're permitted to cross multiply. By cross multiply, I mean we multiply along each diagonal. One diagonal gives us 6x. The other diagonal gives us 24 times 10. I've avoided multiplying 24 by 10 to make the reducing process easier. So at this point, I divide both sides by 6. I now cross out the 6's, and I'm left with x equals, well, 6 into 6 is 1, and 6 into 24 is 4. So the result is 4 times 10, or $40. And we see that this corresponds to choice D. Problem number 25 is a percent increase word problem. The price of a house increases from $200,000 to $250,000. They want to know what percent increase that represents. Percent increase word problems, along with percent decrease word problems, are two of the different types of percent word problems. You'll find many different variations in the way professors, textbooks, and websites solve these problems. However, the variations fall into two general categories, namely formulas and proportions. Let's try the formula approach first. Using this approach, you'll see that percent word problems generally have three values. The percent, this is the percent of the whole. The whole, this is the amount to which the percent is applied. And finally, the result, which is the amount after the percent is applied. Now these values are related to each other by the formula P times W equals R, where P and R must refer to the same value. For instance, in this example, P is the percent increase, so therefore R will be the amount of the increase. Other textbooks may use other letters than P, W, and R, but the idea is the same. I chose P, W, and R because they refer to the quantities that we're discussing here, but also it's easy to remember. You just power it up. P, W, R, P times W equals R. So we're now ready to solve the problem. We'll write down the formula, P times W equals R. Now they want the percent increase, so P is going to refer to the percent of the increase, which means R has to also refer to increase. In this case, R will be the increased amount. So we're solving for P, and we want to know what is the percent of the home that raised the price to $250,000. So the percent of the whole is going to be the percent of the $200,000. Now the result has to be the increased amount. Well, the new amount is $250,000. That's not the increased amount. That's the new amount. To figure out the amount of the increase, we have to subtract the original amount. And if we do that, we see the increased amount is $50,000. So this is the amount we will now plug in to the R representing the increased amount. So we can now divide both sides by 200,000. On the left, the 200,000s cross out, and we're left with P. On the right, we see that 4 zeros will cross out, and you're left with 5 over 20, which can be reduced to 1 over 4. And if you know that that's 25%, you're done. A lot of people know that. So that is the answer. If you don't know that 1/4 is 25%, or you're not comfortable reducing the 5 over 20, at this point, when you've gotten to 5 over 20, you can do long division, and you'll have 2 20s in 50, and then you'll finish with 5. 5 times 20 is 100. Now remember that P is a percent, so you'll have to convert this to a percent by moving the decimal 2 to the right, and once again, you'll get 25%. Alternatively, we can solve the problem using a proportion. The proportion is the whole is to 100% as the part is to X%. Now the part in which we're interested in is the increased amount. Since we want to find the percent increase. So let's plug in. The whole is going to be 200,000. And the part, the increased amount, is going to be found by subtracting the new value of the house minus the original value of the house to give us $50,000, the way we saw in the power formula. So now we have a proportion, we've filled it in, and all we need to do is cross multiply. So you can follow the steps here where we cross multiply, and we wind up crossing out 5 zeros over here, 5 zeros over here, and you're going to be left with 5 times 10 over 2. 2 into 2 goes 1, 2 into 10 goes 5. So we're going to be left with 25%, just like we saw before. And so the correct choice is choice C. I hope you have benefited from this video, and good luck.